This is one of my castings from my last video, melting cast iron with propane. Now what I've got to do is machine along here, so it's a sealing surface, and this rubber washer sits on top of it. Got the casting in the chuck, and what I'll do, it's a rough surface there, uneven. I'll use the tip tool first to get most of that roughness off, and then I'll use a high-speed parting tool to cut the slot so the rubber washer will hold in place. Now I've got my calipers and I'll measure the slot diameter. Then what I'll do, just use a rule across there. That's good enough. That'll tell me when I'm at the correct depth. And now we'll try the rubber washer. See how it fits. Perfect. So what happens is, that's machined, that face, that's a gasket, and there's a brass ring inside the well pump, and that seals that part there. Here is a close-up of the well pump, one-way valve. As you can see, they're very thin sections, prone to chill, and this cast iron batch was very soft, lovely to machine. All the one-way valves have been machined, the rubber washers installed, and this is where they go. This is an inspection cover for this well pump. Now what I need to do is cut a thread in the lathe, but to do that I need to make sure that it will fit inside here. Now this casting is very heavy, so what I've got to do, I'm going to have to make a die nut, because it'll be too awkward to lift that nut or that casting onto the lathe and try it all the time. Now here is the reason why I replaced that inspection cover. It's rather mutilated, and I've just picked up a good one out of 4 of them and used that as a pattern. Before I can cut the thread on this cover, I'm going to have to use this cover and cut a die nut or a test nut to make sure this screws in properly. And then once I've finished that, then I can cut the thread on this one and try it in here, and to make sure it'll actually fit in the pump housing. I used a pitch gauge to measure the thread on that cover. That's 10 threads per inch. Unfortunately, it's a non-standard thread. It's commonly called a bastard thread. So this is where I've got another reason why I've got to make that die nut, test nut, to make sure it fits. Now I need to check it with the pitch gauge. Yep, 10 threads per inch. Here is the big test, and we'll see if the cover will screw into the die nut. Yep, works. So, when I cut this thread on the new cover, this thread here will make sure that that is exactly the right size and it'll fit into the well pump housing. The cover has been securely clamped in the 3-jaw chuck. By rights I should use a 4-jaw chuck because castings can be uneven. But here is a little trick I can show you how to get around that. Now I'll switch the lathe on and you'll see it running out. So what I'll do, because there's a hexagon bar on the end, I'll change it round to several positions and get it running a lot truer than it is now. Now what I've done, I've rotated the casting about 60 degrees, which is one flat on the hexagon, and have a look at the difference now, how good it's running for trueness. That can save you a little bit of work and time. I've just taken a light cut and to use the pitch gauge and to make sure I've got 10 threads per inch, which it is. So now I can cut the rest of the thread. I've cut the thread to full depth and we'll just try on our die nut. Screwing on. Yeah, it screws on virtually all the way. There's a bit of a gap just here. I'll have to deepen the groove at the end of the thread. It's catching just there. We've got our little radius tool just in there, and we're just going to open that groove up a little bit so it'll screw to the very end. We'll try it this time and see if it'll go to the very end. Yep, we got a winner here. And here is a close-up of the inspection cover. This machined quite well. There's the thread and there's the cover part. Lovely cast iron to machine.